So we talked about a few characteristics before. Now we're going to talk about just a few more characteristics of polynomials. We're going to first start looking at extremas, and this is something we've already discussed. Your extremas are your terms in your graph. So if you're given the graph, you take the amount of terms you have, add 1 to get the least possible degree of the polynomial. So in this example, I have 1 term, 2 terms, 3 total terms. I add 1, and that tells me that this is a polynomial with a degree of 4. I can look at the function, so without the graph, and I can take the degree, which is your highest exponent, and subtract 1 to get the extrema. So here my degree is 3. I subtract 1, and I get 2 extremas. So let's look at an example. What is the least possible degree of this function? We take the number of terms. I have 1 here, second one here, so 2 terms. I add 1 to get 3. Same thing with this example. I have 1 term here, 2, 3. 3 terms plus 1 gives me 4 extrema. Now I just do the inverse when I'm looking at the function and not the graph. So my degree is 4. That's the highest one. 4 minus 1 tells me I have 3 extremas. My highest exponent in this next one is 5, and 5 minus 1 gives me 4 extrema. And then in this last one, my highest exponent is 3. 3 minus 1 gives me 2. So this is how you find the extrema, or the number of extrema, if you don't have a graph. Now let's look at end behavior. End behavior is telling me what's happening to my function based on, or to my graph based on the function, and vice versa. So if I look to the left, where's the function going? If I look to the right, where's the function going? So as I'm going towards negative infinity, is the function going up or down? If I'm going towards positive infinity, is the function going up or down? So this, you're always using positive and negative infinity. So let's look at an example. So I have my first example here. And I'm going to say as x goes towards negative infinity, the function's going where? And as x goes towards positive infinity, the function's going where? So you're going to start out writing this first part every time, because all you're worried about are these answers right here. So this will never change. So as x goes towards negative infinity, so as my x values are going towards negative infinity, where's the function going? It's going down towards negative infinity. As I'm going towards the right, where's my function going? Up towards positive infinity. So my setup is the same. So x goes towards negative infinity. What is the function doing? As x goes towards positive infinity, where's the function going? So as I go to the left, the function's going up towards positive infinity. As I go towards the right, where's the function going? Up as well to positive infinity. So again, these last pieces are the only things that are going to change. This is all we're looking for. So these will be different. They could be the same. They could both be negative, both be positive. But the only part that stays the same is this part will change. So let's look at a couple more. Again, how we start off is still the same. Where is f of x going? All you're looking for is this end part. So try this on your own and see if you get the right answer. Do the same thing for number 4. You can pause this video if you want to check yourself. As x goes towards negative infinity, I see that the function's going up, so my answer here is positive. And as I'm going to the right towards positive infinity, the function's going down towards negative infinity. And then I'm looking at this last one. It's the same answer. I start with the first part every time. My function, as I'm going to the left, is going down towards negative infinity. And as I go to the right, it's still going down towards negative infinity. Okay, so now let's look, if we're given the function, how is the graph going to look? So biggest thing, there's 2 things to look at. One, you want to look at the degree. And then you also want to look at the leading coefficient. You want to know if it's positive or negative. So what we're going to do is first look at this first example. The degree is 4. If the degree is even, and behavior is the same. So they're both going to go in the same direction. It just depends on whether it's positive or negative. So we set up the first part the same way. Our degree is even, so they'll be the same. And since our leading coefficient is positive, they are both going to be positive. So if there was a negative in front of the x to the 4th, these both would be negative. So this function roughly is going to have 3 turning points. I'm going to show what this looks like in a minute. But I'm going to have 3 turning points, and they both are going to start at positive. So your function is going to look something like this. Then I look at this one. I have degree 5. It's going to be 4 terms. And if the degree is odd, your end behavior is different. So one will go one way, one will go the other. So again, first part always stays the same. And so we're going to look at this first part, and I'm going to do a rough sketch so you can see. So any positive function, it always starts from the bottom. So if I have a cubic, it's going to look something like this. If I have a degree 5 polynomial, it's going to look something like this if it's positive. What happens is if I have a negative out front, it flips this entire thing. So it's actually, instead of starting down, it's going to start up. So this is what my degree 5 will look like. So if it's positive, it'll look like this. If it's negative, it's going to look something like this. So as x goes towards negative infinity, I see that my function's going up towards positive infinity. And as I go to the right towards positive infinity, I see that my function's going down towards negative infinity. If I look here, I have a cubic. I have, my setup is the same. And so I have 2 terms. So this is my positive cubic. It's positive, so it's going to start negative. So as I go towards negative infinity, it's going towards negative infinity. And then as I go this way, it's going towards positive infinity. So both of these have a negative number for their degree, an odd number for their degree. So they're going to have different end behaviors. And then if it's positive, it's going to start out negative. If it's a negative function, it's going to start out positive. So let's look at this. It says, tell me what do you know about the equation? And we know that it's an even degree because they're both going the same direction. And it's a negative leading coefficient because it's going down. So since they're both going down, means it's a negative leading coefficient. Now look at this one. I see that one end is going down and one is going up, making it an odd degree. So different directions. And I know it's positive because it starts out going up. So the function's going up, but my end behavior is down. So if we do rough sketches, we can look if they give us these zeros. So our zeros are at -10 and 2. I know it's going to cross at these 2 points. I have one turning point because I take my degree and subtract 1. So I have one turn, and the beginning is positive, so my end behaviors are both going up. So I know that if it's got a cross here, I just want to draw my function so it looks like this. So the number of zeros, I have 2 zeros. My y-intercept, we can take a look at, we'll look at that in a minute though. Let's do another little rough sketch. My zeros are at -2. I have -1, -2, and +1. I have 2 turns, and it's going to start with my end down because the function's going up. So I'm going to start going up, turn at -1, turn again at 1. So I have 3 zeros because my degree is 3. And let's look at y-intercept now. Your y-intercepts are easy. It's just whatever your constant is. So this is a -2. My y-intercept is -2. Up here, this is -20. So my y-intercept is -20. So that's how you do a rough sketch of a polynomial function given the zeros. So given the function and given the zeros. You can also factor this to get your zeros. So I want to show you one thing is how to get your zeros based on the function if they don't give you your zeros. So we're going to use our graphing calculator, and we are going to go to y equals. So in your calculator, you're going to hit y equals, and you should get what this looks like. And we're going to put this function in. So I put in x, which is right here, x squared plus 8x again, and then minus 20. So minus 20. So right here I have exactly what's here, and then I want to see my table. So I hit second table because I want what's in blue, and then I can scroll. So when x is 0, I get my y-intercept, which is -20. And then where y is 0, I get my x values. So 2, I keep scrolling down. I don't see anything, so I go the other way. And I see another 0, so -10. So my solutions are -10 and 2. Let's look at the other one that we had. We had x cubed. So we have x cubed. Change that to a 3. Then I have a positive 2x squared minus x minus 2. Again, I hit second graph. I come down. So I can look here, and where y is 0, that gives me my zeros, which are -2, -1, and 1. And then when x is 0, I get my y-intercept, which is -2. Now, last thing we're going to look at is our even and odd functions. So a function is even if all the exponents of the variable are even. Odd if they're all odd, and neither if it's a mix of even and odd. So this is fairly simple. Most of them will be neither. All constants have a x is 0 because 0 makes everything 1, and 1 times a constant is that number. And x to the 0 power is even. So anytime I see a constant, it's got an even power. And then a function is even if the graph reflects across the y-axis. Remember, y-axis is the vertical one. And a function is odd if the graph has a 180-degree rotational symmetry about the origin. So let's look at this first one. And if I can draw a line on the y-axis and I see that it is symmetrical, meaning if I were to fold this over, it's going to look the exact same on this side, then the function is even. So it reflects across the y-axis, it's even. This one reflects across the y-axis, so it is even. If I look at this one, if I draw a line down the middle, it doesn't look the same. I can't fold it over and this piece still be down here. So it's not even. We look at odd, we want it to rotate about the origin, which is 0, 0. So remember, origin is 0, 0. So if I take this and I rotate it 180 degrees about the origin, does it look the exact same? And the answer is yes. So this function is odd. So I look at this one. Can I draw a line down the y-axis and it be folded? No. And is it rotating about my origin? So right now it's at -1. If I rotate it 180 degrees, it's now going to be at a +1. So this is not odd. So this function is neither. If I look at an equation, I can see I have a degree 2, then I have a constant. Remember, a constant is x to the power of 0. These are both even, so this is an even function. I look down here, this is even. Remember, this is x to the 0 power, which is even, so this is an even function. Then I look over here, I have x to the 3rd power, this is an odd number. And then x is always to the power of 1, which is also an odd number. So they're both odd. This is an odd function. Let's look at another one. I have x to the 3rd power. This is odd. It's the only one, so this is an odd function. I have the same thing here. This is also odd. I have degree 2. This is even. Remember, constants are always raised to the 0 power. So this is also even. I have 2 evens, making this an even function. Let's look at some more graphs. If I can draw a line down the middle, and I can fold it, and it looks the same. So if I were to fold these pieces, they're going to look the same. This is even. If I can rotate about the origin, which in this case I can, this is odd. Just a couple more examples. This one, I can fold it. This is even. I can't fold this one, and it's not symmetrical. I can't rotate it around the origin, so this is neither. And on this one, can I rotate it 180 degrees about the origin? Yes, it looks the exact same. So this is odd. And then for the last bit, I look at this. I have an odd and an even. So it's neither. I have an odd. This is x to the first power. 1 is also odd. They're both odd, making this an odd. Here I have odd. I have to the degree 1, which is odd. But then I have my constant, which is the 0, which is even. So I'm still mixed up, even if there's more odd, making this neither. So that's how you do even, odd, and neither with polynomial functions. So that's all the characteristics of functions we're going to talk about.